All right. Question number 1A. All right, this question is question number 3 from October 2024. This question has two parts, part A and part B. Part B itself has a 3 parts. So part B, like the first part is just finding the derivative and showing it is something look like this, which actually makes that easy because you know the answer. So your derivative must be like that, and then solving it for x. Like solving quadratic after that. Okay, so the part A itself is just a completely integral of some complex function for x is greater than 0. And yeah, so in order to solve this question, the part A, we should be writing this f of x as the power of x, because that's how we learn in P1. So the f of x can be written as, firstly, f of x can be written as an x squared, x plus 5 squared, as we like x squared plus 10x's and plus 25. I used binomial identity. Okay, so you can multiply x plus 5 by x plus 5 is basically by itself as it's squared, and then instead of square root of x, I'm going to write x to the power of half. So that gives us the x squared divided by x to the power of 1/2, and plus the 10x divided by x to the power of 1/2, and plus 25 divided by x to the power of 1/2. The reason that I do that is I want to write separately each of these terms as a power of x, because it's easy to integrate after that, right? And this question is 4 marks, so we will be getting a mark for writing this expression as a power of x for sure. Okay, so that is going to be written as, this is the final step, actually the step before the final, as x squared minus half plus 10 x to the power of 1 minus 1/2, and then finally 25 multiplied by x to the power of negative 1/2. Okay, so those are the things that I applied the basic index law. If we divide with the same basic of subtracted powers and etc. And then the same here is kind of like, you can imagine that 25 as x to the power of 0. If I apply the same rule, it's going to be x to the power of 0 minus 1/2, which is the negative 1/2. Alright. So now, so you can use a calculator for subtracting these fractions here. It's basically going to be 3/2 plus 10 and 1/2 plus 25 x to the power of negative 1/2. So after that you do the integral of x to the power of 3 divided by 2 plus 10, I forgot to write here, x to the power of 1/2, and then the plus 25 of x to the power of negative 1/2 dx. Alright, the rule you know already from the integral, finding the integral of x to the power of n, like integral of x to the power of n dx is going to be x to the power of n plus 1 divided by n plus 1 plus c. Don't forget the c, it is the must to gain the final full mark. Okay, so we have the same cases here. We have this x to the power of 3/2, we have the x to the power of 1/2, we have the x to the power of negative 1/2. With the 10 and 25 doesn't matter actually. You're going to be just saying the first one is going to be x to the power of 3/2. Okay, let me write it as 3/2 plus 1 divided by 3/2 plus 1 and plus 10 x to the power of 1/2 plus 1, it's 1/2 plus 1, and plus 25 x to the power of negative 1/2 plus 1, negative 1/2 plus 1, and plus some constant, because the derivative of some expression is equals to this. So you should be finding when you're finding the integral, you're basically increasing the power and dividing by the power, because that's how you find the derivative, right? So when you find the derivative of x to the power of n, so you're going to be saying that's going to be n x to the power of n minus 1, right? So there will be n times, so you should be dividing by the n, like power plus 1, that's basically for this. And then we are adding 1 to the power of x because we minused 1 from it. We're basically bringing it back, okay? So basic integral you need to remember as an antiderivative. It's like basically completely opposite operation you can think of to the derivative, okay? Instead of multiplying by n, we just divide by n, imagine in this way, and etc. So this constant, like 10 and the 25, and for example here we have actually the 1 there, we don't write it, they are also going to be multiplied. You just keep them there, okay? So finally I can say on the first one it's going to be x to the power of 5 divided by 2, and the same here, 5 divided by 2, plus 10 multiplied by x to the power of 3 divided by 2, 3 divided by 2, and plus 25 multiplied by x to the power of 1/2, and then there will be a 1/2 on the denominator, and the 25 times there, so that's, let me write this closer to 25, and then you're gonna say plus c. Don't forget c, once you integrate it, you gotta write plus c. Okay, so a lot of students are doing a mistake on the last step. I'm talking about this one, okay? So there's a denominator 5/2. Okay, so I'm going to write only for 1, the rest I'm going to do automatically, and you should be obviously understanding it because you took the IGCSE mathematics, okay? I'm only going to show the for the first one, okay? So x to the power of, if we have x to the power of 5 divided by 2, and that's divided by 5/2, this is the same as you're dividing x to the power of 5/2 by 5/2, okay? So I mean, instead of this fraction bar, we're writing in division in between, okay? So what do we do when we divide the fractions? We keep the first one as it is, we multiply it by the reciprocal of the second fraction, okay? So what happens now is 2/5 x to the power of 5/2, all right? This is what happens for each and every terms of this expression here. Alright, so the first one is going to be, we already said that over here, 2 divided by 5, x to the power of 5/2, and plus, since it's a coefficient, there will be a little simplification here, maybe or maybe not. So you got to be very careful about it, okay? If there's something you simplify it, because I believe they don't say it, but I believe they want is fully simplified form. In the mark scheme, they might gonna give you the mark, they might gonna deduct your mark or reduce your mark 1 mark because of you didn't simplify it, okay? So you gotta simplify that. So for this fraction, we are going to have the same here. Just flip it. It's like gonna be, it's 3/2. It's gonna be 2/3, and times 10. That's gonna be 20/3. X to the power of 3 divided by 2. And plus, so this fraction on the denominator, when you flip it, it's going to be 2/1, which is 2 times 25 will be 50 on the top, times x to the power of 1/2, and plus c. So 2/5 x to the power of 5/2 plus 20/3 x to the power of 3/2 plus 50 x to the power of 1/2 plus c. So that's pretty much done for part A. Now we're on part B. Part B has 2 parts. Part 1, it says we need to be finding the derivative of f of x, and showing that can be written as 3x squared plus 10x minus 25, which is equals to 0. Okay, so so what we're going to do here is I'm going to be taking the f of x. So I already used the simplest form of f of x in the derivative, so why not take it and use it in the derivative also? Use it in the integral. Actually, I'm going to use it in the derivative, okay? So this is an f of x, okay? So I'm going to say, okay, this is an f of x which we found it on the previous exercise. So you don't have to do this again, you know it already, so let's just use it on the second part. So if I'm looking for a derivative, so remember this notation stands for the derivative of f of x. So they basically right now testing you whether you understand the meaning of this sign, which is derivative, and then if you understand this, you know how to find the derivative or not. Okay, they're testing this. 3 over 2 plus 10x to the power of 1 over 2 plus 25x to the power of negative 1/2. Okay, so the first thing that I'm going to do is find the derivative. Let's put a sign over there. Okay, so the rule for the derivative, if I have an x to the power of n of the derivative, so it's going to be, actually this is over there, I'm going to do it one more, it's going to be nx to the power of n minus 1. That's how we do the derivative. Okay, for the x to the power of 3, I'm going to doing this separately. I could do this, do this, do this. I might can write them separate derivatives or just do it directly. I'm going to start with the first one as x to the power of 3 over 2 will be power times 3 over 2 minus 1. Same with the other one. There's a 10 over there, be careful with that. Power times power minus 1, x to the power of power minus 1. Okay, so this is the second one, plus 25 times, and there will be a power multiplied by x to the power of power minus 1. Okay, let's simplify this, then I'm going to equalize it to 0. That's going to be 3 divided by 2, x to the power of, you can subtract the fraction on the top using your calculator. That is going to be 1/2. 3 minus 2. So 10.5 simplify to 5. On the top you're going to have a negative 1/2, and 25 and then minus 25 over 2, x to the power of negative 3 divided by 2. Alright. Now this is a final derivative. So then what I'm going to do here is I'm going to take this expression because they want us to show it can be written as 3x squared plus 10x minus 25. Okay, so I'm going to take this expression and I'm going to be equalizing this to 0, and then I'm going to do a adjustment on this, adjusting this into the form they want. Okay, so I'm going to be multiplying everything by 2 first. Okay, so get rid of the denominator in the coefficients. That's going to be 3x to the power of 1/2 plus 10 x to the power of negative 1/2 minus 25 x to the power of negative 3 divided by 2. That's equal to 0. Okay, so what do I do now is I want to have an x squared. You can think of this actually, I mean the process I'm going to do here, you can think of this as factorizing the expression, or you can say, alright, I'm going to multiply everything by x to the power of positive 3 divided by 2. That's the smallest one. In between these powers, like this is 0.5, negative 0.5, negative 1 point smallest one. And by doing so, we are going to have x squared, we are going to have x, and we are going to have the constant term. Okay, so you remember that as I told you that I'm going to tell this again, I told you that you can think of this factorizing this expression. Okay, x to the power of 3 divided by 2. Why positive? Because if I multiply this by that's basically going to be x to the power of 0. We're going to have here 25 only. Okay, and the same applies to the other ones. Okay, so I'm going to write all the detail. It's going to be 3x to the power of 1/2 plus 3 divided by 2. Okay, so remember we multiply everything by that. 10 x to the power of negative 1/2 plus 3 divided by 2, and minus 25 x to the power of negative 3 divided by 2 plus 3 divided by 2, that's equals 0. 0 times anything is 0. So guys, you are already related. That's going to be 3x squared plus 10 to the power of x, sorry, 10 times x. The power 1 is just going to be 2 divided by 2 on the power. You can add this with your calculator if you want so. And the last one, the final one, is going to be 25 is equals to 0. So what we do is just we go and check 3x squared plus 10x minus 25. Is it the same as what they say? 3x squared plus 10x minus 25. So we have exactly the same answer. Okay, you will be getting a mark for finding a derivative correctly. Okay, so finding the method mark for finding a derivative, and then accuracy mark finding everything correctly, and then equalizing to 0. And even in the mark scheme they says you are going to be getting dependent mark method mark, actually dm1, for multiplying everything by x to the power of 3 divided by 2, and then solving it, adjusting it into 3x squared plus 10x minus 6, going to be a1, which is the accuracy mark in at last. Okay, and then the final is hence state the value for x for which f dash f, derivative of f of x equals 0. It's going to be your final 1 mark. This is the second part, where I right now know f dash of x equals 0 is the same as 3x squared plus 10x minus 25 equals to 0. Okay, so what I need to do, I need to be showing this has a root. Where is this has a root or roots? And then I mean actually it's going to have only one root, because they say on the top x is greater than 0. Let's just write that 4x is greater than 0. Just only we're going to be taking a positive root here. Okay, can we factorize it? I'm thinking of the factorizer. Presumably it's factorizable. I'm gonna just give it some couple of tries. And if I take this with the x over here, okay, so I'm gonna thinking of to take this as a minus 5, and then this one is a plus 5. I'm gonna be checking this. 3x squared 15 positive 15 minus 5 minus 20. I think this is the one. Gonna double check with 3x squared, yes, plus 15x is minus 5x is gonna be 10x in the middle. Yeah, so we are going to be having only one root here, x equals to 5 divided by 3. I mean, this one is the only root as x is greater than 0, because if I look at the other one is x is negative 5, which if we don't take it, that's the only one. Okay, always watch out for this. If you take the both, you're going to be losing a mark. Well, that's it.